Hello everyone. In this video we will talk about trigonometric antiderivatives. By trigonometric antiderivatives I will mean one of two types of integrals. So the first will be somewhat self-explanatory. So these will be integrals of the form sine to the m of x times cosine to the n of x. So we'll see different powers of sine and cosine. So this is trig because we're dealing with trig functions. The other one, it's less clear how trig shows up. So these will be dealing with roots of quadratic expressions. So what I mean by this is something like the integral of dx over the square root of x squared plus 2x plus 5, right? So we have a quadratic expression inside the square root, and somehow we're going to use trig to figure this guy out. Okay, so we will go over both types in this video. So the first one we'll look at is the powers of these trig functions. So the easier case will be when at least one of m and n are odd. So let's go ahead and actually just look through an example and try to figure out what's going on. So let's suppose we have something like cosine cubed x sine to the fourth x dx. Well, clearly one of these is odd, so that's a good start. So how do we do this? So here's where we have to remember that sine squared plus cosine squared is 1. This is going to be vital because we know that sine and cosine, their derivatives relate to one another. The problem is if we want to use a u sub where, like, say u is sine or u is cosine, well, we need one of these powers to be exactly 1 to get our du lined up right. So in this case, since cosine has the odd power, this is the one we want to reduce to the first power so that u will be sine. So we want to think u is sine x, and so du should be cosine x dx. So cosine is the one that we need in the first power. So, well, using this over here, I know that cosine squared is 1 minus sine squared. So I'm going to rewrite this as, okay, I've got a cosine. And then I'm going to peel off two of these cosines and rewrite it as 1 minus sine squared. And then keep my sine to the fourth. Okay. Well, I can distribute out these two pieces, right? And then I am left with, sine to the fourth x minus sine to the sixth x cosine x dx. Well, now I'm ready for my u sub, right? So I have now written this as u to the fourth minus u to the sixth, and then cosine x dx is my du. And now I'm good to go, right? So it's 1/5 u to the fifth, or sine to the fifth x over 5, minus sine to the seventh over 7, and then plus c. So the key here is seeing, okay, which one is odd? I can reduce that one to the first power. Sometimes both will be odd, in which case you just kind of have your pick. And then you'll use a u sub with whichever one is not the one you're reducing to the first power. But then you may ask, what if m and n are both even? So here we'll have to make use of some more trig identities, what are called the half angle or sometimes the double angle, depending on which way you're coming from, identities. So here are the formulas. So we're not going to do a very complicated one, but let's just try to figure out, okay, how am I going to do, for instance, just the integral of cosine squared x? So in this case, right, we're not able to reduce, well, one, we see sine to the 0, and so we can't really use a u sub here. So our only way to get down to a first power is to use this first formula and then a u sub with the 2x. So let's see this in action. Okay, so just using that formula, we get this equality, and then we can split this up. So this is just like the integral of 1/2 dx plus, 1/2 the integral of cosine of 2x dx. So the one on the left is pretty easy. The question is, how do we do the one on the right? Well, that would be just a really quick u sub where u is 2x, right? So du is 2 dx. We see dx there, so we just get the du over 2 is dx. And so what do we get? Well, that'd be cosine of u, but it'd be 1/2 cosine of u. So we would just get sine of 2x. So this ends up being 1/2 x plus 1/2 times the integral of 1/2, getting ahead of myself, cosine of u du. So that's 1/4, so we get 1/2 x plus 1/4 sine of 2x plus c. Okay, so for your first exercise, I want you to integrate tangent cubed, but I'll give you a hint. So you're like, how does that apply to what we just did? Remember, tangent is sine over cosine, so this is sine cubed over cosine cubed, or sine cubed x cosine to the minus 3x dx. Okay, so both of these are odd, so you can basically reduce whichever one seems easier to you. So pick one, use that first method, and see what you can get for this integral. So dealing with these rational or radical expressions of quadratics is something called trig substitution. So the main things that we can deal with are things of the form where a is a constant here, a squared minus x squared minus a squared, and a squared plus x squared. And basically these three will all involve different trig functions, but they work fairly similarly. So let's take a look at one of these integrals. So consider just the square root of 1 minus x squared dx. So this maybe looks a little bit like arc sine, right? Except for it's not 1 over. That's maybe the only intuition we really have on this. So I can just give you a little bit of guidance here and say we are going to do, so this is going to look a lot like u substitution, but we're substituting with a trig function. So here we are going to let x be sine of theta. So in that case, again, we're going to change this basically into an integral only in the variable theta. So we should figure out what dx is. Well, derivative of sine is cosine. So we get cosine theta d theta. So let's rewrite this. So with this new variable, this is the square root of 1 minus sine squared theta, cosine theta d theta. But of course, we know that 1 minus sine squared is equal to cosine squared. And since it's under the square root, that is just cosine. So we've actually just reduced this to cosine squared theta, something that we just did previously, right? This is an even power one, but this is one that we did. So we can use those half angle formulas again, and I'm just going to write down what we got last time. So we get this expression, and now you may want to, well, we definitely want to get this back in terms of x. One part is easy, one is not so easy. Right, so the first part, what is theta? Well, if x is sine theta, then to solve for theta, we do arc sine, right? So theta is just going to be arc sine of x. So we could sub that in here, no problem. The problem comes when we do this sine of 2 theta. We know what sine of theta is, that's x. We could do an arc sine to get theta, but then we don't really have a nice way to do sine of 2 times arc sine. We could do 2 sine of arc sine, but the 2 is an issue. So this is where we'll use another formula. Yes, we are going to be testing your trig identity skills here. So it's a fact that sine of 2 theta is the same thing as 2 sine of theta cosine theta. So this is nice because suddenly we are down into just single thetas. We don't have to worry about the 2 anymore. So I'm going to rewrite this. So this part's good, right? So this is 1/2 arc sine of x. And then what do we have here? So 1/4 times 2, well, that's 1/2. And then I just get sine theta cosine theta plus c. Well, sine of theta is just x, right? This guy's x. But what's cosine theta? We don't have that. So, I mean, we have it in terms of dx, but like we don't want a dx showing up after we've taken an integral. So you may remember way back when we were solving for derivatives of inverse trig functions that we used triangles. Well, we're going to do the same thing here. So here I have a triangle. What's my angle? Well, I've been talking about theta this whole time. So theta is my angle. And then I know that x is sine of theta. So sine is opposite over hypotenuse. So this should be x over 1 because I just want x. Well, what must my remaining side be? This has to be the square root of 1 minus x squared. And so if I want cosine, it's adjacent over hypotenuse. Cosine is just going to be the square root of 1 minus x squared. And so your final solution, I'm going to pull out the 1/2. You get 1/2 times arcsine plus x times the square root of 1 minus x squared, and of course plus c. So there are a lot of moving pieces here, so let's do maybe one more quick example. All right, so let's take a look at this guy. So if you see x squared plus 1, x squared plus a squared in general, you want x to be a tangent theta. A here is 1, so it's just going to be tangent theta. And then dx is secant squared theta, d theta. So this simplifies to this. And then it's good to know the trig identity. So sine squared plus cosine squared equals 1. If you divide through by cosine squared, you get tan squared plus 1 is secant squared. And so secant squared is what's really inside this square root. So that's actually just a secant. Okay, so we can cancel a secant. We cancel a power of the secant there. And now we're kind of stuck because we would maybe want u to be tangent because that's like an inside function, but then du would be secant squared. We only have one secant showing up, and I don't see any other nice way. So when in doubt with trig, break it down into sines and cosines. So secant is 1 over cosine. Tangent is sine over cosine, but it's in the denominator. So we flip that and make it cosine squared over sine squared for tangent squared, d theta. So then what can we do? Again, we cancel out a power, we cancel out a cosine. And now you should notice sine is an inside function. It's squared, or to the minus 2. And its derivative is right there. So if u is sine theta, and du is cosine theta d theta, we can finish this off, right? So now we get 1 over u, or u to the minus 2, 1 over u squared, du. And so you end up with negative u to the minus 1, or negative 1 over u plus c. But what was u? It was sine theta. So negative 1 over sine theta, or cosecant theta, plus c. And now, for the last step, I want you to do it. So this will be your second exercise. So we got down to negative 1 over sine theta plus c. I want you to use the fact that we know x is tangent theta and a triangle like we did before to rewrite this in terms of the variable x. All right, thanks for watching.